At the intersection of computer code and human language, what was once merely a dream in science fiction is becoming a tangible reality. Large language models, or LLMs, are not simply programs that predict the next word. They are the culmination of decades of effort to decode human thought into mathematical patterns. Imagine a library housing the entirety of civilization's knowledge in one place, inhabited by an intellectual entity capable of reading, comprehending, and connecting every single character in a fraction of a second. This marks the beginning of a grand journey to explore the intricate structures hidden beneath these intelligent responses. We will witness how machines learn to understand the meaning of love, anger, and even complex mathematical logic through the world-altering process known as deep learning.
The crucial turning point for everything occurred in 2017, when a research paper titled "Attention is All You Need" introduced an architecture known as the transformer. Previously, artificial intelligence struggled significantly with retaining long-form content. It would often forget the beginning of a sentence by the time it reached the end. However, the transformer introduced a mechanism called self-attention, which is akin to a human mentally highlighting key points while reading. This mechanism enables the model to perceive the relationships between every word in a sentence simultaneously, regardless of the distance between them. For instance, when considering the word bank in a sentence like, "He sat by the riverbank," the model can analyze the surrounding context to instantly determine whether it refers to a financial institution or the land alongside a river. This is the foundation that grants LLMs a depth of contextual understanding thousands of times greater than previous systems.
However, a robust architecture alone is not enough. It demands immense energy and raw materials, data, and computing power. The pre-training process is the phase where the LLM is fed colossal amounts of data from the internet, ranging from Wikipedia, digital books, and academic papers, to billions of lines of computer code. At this stage, the model is not taught whether a sentence is right or wrong. Instead, it is tasked with predicting the missing word repeatedly, trillions of times. Through trial and error, amidst tens of thousands of GPUs working in symphony, it gradually constructs a network of linguistic relationships. It begins to understand which words tend to appear together and starts absorbing human knowledge without anyone explicitly programming fixed rules. This undertaking requires massive amounts of electricity and extends over several months to forge a complete intellectual structure. Beneath the sleek graphical interface, the reality of the LLM's world is a realm of numbers known as vector space. Every word and concept is transformed into coordinates within a multi-thousand-dimensional expanse. Words like king and queen are positioned in close proximity, while apple might gravitate towards fruit or technology, depending on the context. It is this navigation through numerical space that enables AI to perform semantic arithmetic. For instance, taking the coordinates of king, subtracting man, and adding woman leads precisely to the position of queen. This is the marvel engineers discovered. Language is not merely sounds or letters, but a geometric structure of thought, calculable by high-level mathematics, the vital foundation that allows the model to fluidly answer questions it has never encountered before. Even after a model has learned enough to be omniscient from the internet, it might still speak impolitely or provide inaccurate information. Therefore, the next crucial step is fine-tuning and RLHF, reinforcement learning from human feedback. This is the process where humans step in as instructors by ranking the AI's responses, determining which answer is superior, which is ethical, or which truly solves the problem. This process is akin to polishing a raw diamond into a beautiful piece of jewelry. The model learns to adjust its behavior to align with human values and expectations. It learns to refuse harmful requests and strives to be a polite, helpful assistant. Connecting the AI's goals with human intent, a concept known as alignment, is one of the most significant challenges today. It ensures that this artificial intelligence remains friendly and safe for society. What has stunned researchers most is a phenomenon known as emergent abilities. When a model is scaled up to a certain threshold, it suddenly begins to perform tasks it was never explicitly taught. such as solving complex mathematical problems, writing intricate computer code, or even grasping the nuances of sarcasm. This phenomenon is much like water that, as its temperature is lowered, suddenly transitions from a liquid to ice at exactly 0 degrees Celsius. Scientists still cannot explain with 100% certainty why simply increasing the number of parameters leads to a simulated consciousness capable of such advanced reasoning. This mystery forces us to reconsider a fundamental question. Is intelligence merely the result of data processing at a massive enough scale, or is it something far more profound? Today, large language models have stepped out of the laboratory and into the hands of millions worldwide. They are revolutionizing the way we work and create, from assisting doctors in diagnosing diseases through complex patient histories and helping engineers write code for new innovations, to serving as a thought partner for writers and artists. The power of LLMs lies not in replacing humans, but in exponentially expanding human potential. We are entering an era where language is no longer a barrier to communication, and the collective knowledge of the world can be accessed through just a few lines of conversation. However, we must remain vigilant in facing challenges regarding data accuracy, ethical usage, and preparing for the massive economic shifts that will inevitably follow the arrival of such advanced artificial intelligence. Looking back, the development of large language models may stand as the most significant milestone in technological history, comparable to the discovery of electricity or the birth of the internet. It is a bridge between silicon and the soul, demonstrating that we can distill the collective wisdom of the human race into an inanimate form. The journey of LLMs has only just begun. In the near future, we may witness artificial intelligence with a depth of understanding that far exceeds our current imagination. Yet, no matter how advanced the technology becomes, the most vital factor remains how we choose to use it, to create something meaningful, and to lead our civilization toward a future that is more sustainable and more humane. Thank you for joining us on this journey through the world of large language models. We hope you can see the limitless potential hidden within every single character of this artificial intelligence.